So today we're going to go from a $5 telescope to a $5,000 telescope. From here all the way around, working it, eventually to that. To start off, got to start small. Look on Facebook and maybe you'll get lucky and you can spend your lunch money on a Celestron FirstScope 60mm aperture Newtonian reflector. The light going down to that main mirror, that's terrible, and bouncing off that mirror 45 degrees to focus in your plastic 1/2 ounce weight light eyepiece. It lets you see the moon, and you can see that a planet is in the sky, but you might not be able to tell which one. And then you can get, after that, a different kind of telescope. It's a Celestron TravelScope 70mm refractor. And this works in a different way where the light comes in through that lens, and that lens system, too, in this one, ends up focusing the light to here, where you look through your eyepiece. You've got your focusing knob right here, and a pretty terrible tripod. Hard way to track what's in the sky as it moves. But you can at least make out Saturn and Jupiter, and definitely the moon. Then you can get something like this, which is really a more premium travel scope, a Celestron C90 Schmidt Cassegrain system, which is kind of a combination of the two we just looked at, where light comes in, hits that main reflector back there, then bounces off the secondary mirror, then goes through a little tube down the middle into your eyepiece where you can focus it right there. And that's not so bad. This tripod you can get with it, $100, $250 for the scope. And it's a good way to track stuff, especially in a grab and go setup, because you got these slow motion controls here and it's pretty stable. If you want to look at the sun, you can pick up one of these, and it's only for looking at the sun and only some hydrogen emitted light, nothing else. You can skip past this. That's just decoration, and it felt like it was being left out. Eventually, you get your $500 telescope here, an Orion XT8 Dobsonian 8-inch Newtonian reflector. The same exact optical design as the FirstScope, just in a much bigger, more well-made design. Light hits that, bounces up to here, focuses in through your eyepiece. That's a great way to see planets, a great way to see the moon, and you can even image Mars, Jupiter, Saturn, stuff like that, like I did. But if you want to get better pictures of the solar system, you need to start tracking. And then you might pick up this Celestron NexStar Evolution 9.25-inch Schmidt Cassegrain reflector that works a little bit different. And that is kind of like the Maxitov. And it's the same as this scope here, where you've got light coming in, bouncing out the main mirror, the secondary mirror, and then down the tube into your eyepiece. But you got to get a mount for it, much like the Celestron CGX, which is weighted to carry 45 pounds of equipment on top of it and track objects in the sky with the Earth's axis with perfect rotation for hours at a time. And this way you can get outside the solar system and you can see things very far away, like other galaxies. And what helps that is stuff like the Celestron StarSense automatic alignment tool, which will take a picture of the stars and then tell that to the mount, so the mount knows exactly where it's pointing and align itself to the sky without you having to manually do it. And after you get that aligned, you're going to want to start imaging, because imaging and getting in photons, collecting on a camera sensor for minutes and hours at a time is the only way to really get to see what's out there in deep space. And you need a mount that can track accurately for those minutes and hours in order to get those images that will show you what's out there. And something like this guide scope setup right here, that will tell a computer that is controlling the mount, getting information from it, if a star in the field of view is changing up, down, any direction, and then have the mount via the computer compensate for that tracking error within a second, so that your 30-minute long exposure doesn't start to get blurry. And then that way you get the sharpest, clearest, longest, deepest views, millions of light years away, for $5,000. Whereas for $5, you can't go more than 1 light second to the moon. And then you start to bump it up a little bit. For $500, you can go about 30 light minutes into the solar system. And then when it's all said and done, you're still not satiated, but at least you can go thousands and millions of light years into deep space outside of the Milky Way galaxy.